You see billions of stars, twinkling like celestial fireflies scattered across an infinite canvas. You see the faint, majestic swirl of distant galaxies, vast islands of stars spiraling through the darkness. It's breathtaking, isn't it? It fills us with this incredible sense of awe and wonder. It makes you feel tiny, yet connected to something immense and beautiful. For centuries, we've gazed at this spectacle, admiring its beauty, charting its movements, trying to understand its scale. But what if the universe is more than just this stunning visual display? What if its beauty is just a consequence of something far more fundamental, something that's constantly happening just beneath the surface of what we can perceive? This is where things get truly mind-bending. What if the universe isn't just a stage upon which events unfold, but is actually a colossal, dynamic, self-calculating entity? What if it's a giant quantum computer, constantly processing information, running an unimaginable program that generates everything we see, touch, hear, and feel? Think about that for a second. Everything around you, the chair you might be sitting on, the device you're watching this on, the air you breathe, the thoughts in your head. What if all of it is the result of incredibly complex, fundamental computations happening at the deepest level of reality? This isn't just a whimsical thought experiment. This is a serious idea being explored by some of the brightest minds on the planet, physicists and cosmologists who are peering into the deepest mysteries of space and time. They're uncovering tantalizing clues, hints buried in the very fabric of reality, that suggests the universe might operate on principles eerily similar to our most advanced technology. Quantum computers. Let's try to get our heads around this with an analogy. Imagine you're baking a cake. It's a familiar process, right? You gather your ingredients: flour, sugar, eggs, butter, baking powder. You carefully measure each one, ensuring just the right balance. Each ingredient plays a crucial role. The flour gives it structure. The sugar provides sweetness. The eggs bind it together and add richness. You mix them, put them in the oven, and through a series of chemical reactions governed by the recipe and a bit of heat, you get a delicious, complex cake. Now, imagine the universe as a cosmic cake, but its ingredients aren't flour and sugar. Its ingredients are the most fundamental elements that make up the fabric of reality itself. These aren't things you can hold in your hand or measure with a cup. They are tiny, incredibly small particles. Things like electrons, quarks, photons. These minuscule entities are the ultimate building blocks. They combine in countless ways, following specific rules and interactions to create everything in existence. From the smallest atom in a grain of sand to the largest galaxy sprawling across light years. They form the chair you're sitting on, the screen you're looking at, the blood flowing through your veins, the stars light years away. They are the foundation of the diverse and complex world we inhabit, from the breathtaking beauty of a forest to the roaring energy of a city. But here's where the idea takes another leap. What if these particles are more than just tiny lumps of matter? What if they hold a deeper significance, a hidden layer of reality we're only just starting to glimpse? What if, at their most fundamental level, they aren't just physical objects, but are also carriers of information, like the zeros and ones in a conventional computer, or perhaps something far more complex, far more quantum? This perspective suggests the universe operates much like a vast, cosmic computer, processing information. At this deepest, most fundamental level, the particles aren't inert building blocks. They are like the bits of data, constantly interacting, changing states, and communicating with each other in ways that generate the reality we experience. This is the essence of the quantum view of the universe. In this mind-bending framework, particles aren't just matter and energy. They are also carriers of information. They interact and become linked, entangled, in ways that completely defy our everyday understanding based on classical physics. Just like a computer uses bits, or in a quantum computer, qubits, to store and process information, the universe might be using its fundamental particles to do the same, on a scale that's truly staggering. This idea is deeply intertwined with the strange and counterintuitive world of quantum mechanics. This is the theory that governs the behavior of particles at the smallest scales, and it completely challenges our traditional notions of reality. It introduces phenomena that seem almost magical. Take superposition, for example. In the quantum realm, a particle isn't just in one state at a time. It can exist in multiple states simultaneously. Imagine a coin spinning in the air before it lands. Classically, it's either heads or tails. We just don't know which yet. But quantum mechanically, while it's spinning, it's somehow both heads and tails at the same time. It's only when we observe it, when it lands, that it settles into one definite state. This probabilistic nature, this ability to hold multiple possibilities at once, is a fundamental aspect of quantum mechanics. This quantum weirdness isn't just a strange quirk of the very small. Some believe it could be the key to understanding how the universe computes. The ability of particles to exist in multiple states, to be linked across space and time in bizarre ways, could be the engine driving the cosmic calculations that create reality. By exploring this quantum nature, we might unlock profound insights into the fundamental workings of the cosmos, revealing a universe that is not just a collection of physical objects following simple rules, but a vast, interconnected web of information, constantly processing itself into existence. Think about the laws of physics. Gravity pulls us down to Earth. Light travels at a constant maximum speed. Energy is conserved. These laws seem absolute, constant, unbreakable. We often think of them as fundamental truths about the universe. But what if they aren't laws in the traditional sense of pre-existing immutable rules? What if they are more like lines of code in a giant cosmic program? Just as a computer program follows precise instructions to produce a specific outcome, like rendering a complex image or running a simulation. Perhaps the laws of physics are the instructions, the algorithms that govern how the universe evolves and behaves moment by moment. Every interaction between particles, every event we witness, from the smallest chemical reaction in a cell to the colossal collision of galaxies, could be the result of this cosmic code being executed. The universe wouldn't just be following laws, it would be actively computing them. It would be running this grand, complex program, constantly updating and calculating to generate reality as we know it, frame by frame, moment by moment. This idea leads us to another fascinating concept, the holographic universe. Imagine you're watching a modern 3D movie. The images leap out at you, creating an incredible illusion of depth and space. It feels immersive, almost as if you could reach out and touch the objects on screen, even though you know you're just looking at a flat display. The experience is so convincing that for a while, you might completely forget you're just seeing a projection of light from a two-dimensional surface. The holographic principle suggests our universe might work in a surprisingly similar way, but on an infinitely grander scale. This principle posits that all the information that makes up our seemingly three-dimensional reality could be encoded on a distant, two-dimensional surface or boundary. What if the entire 3D universe we inhabit, with all its depth, its galaxies stretching light years away, its intricate structures, is actually just a projection of information stored on a flat, distant boundary? This idea is profoundly challenging to our everyday understanding of space and time. It asks us to question if the depth and volume we perceive are truly fundamental, or merely an incredibly convincing illusion. This idea, as bizarre as it sounds, isn't purely speculative fantasy. It has roots in the deep study of black holes. Black holes are those incredible, terrifying regions in space, where gravity is so strong that nothing, not even light, can escape once it crosses a specific point of no return, called the event horizon. These cosmic monsters are incredibly dense, warping space and time around them in ways that still puzzle physicists. Some physicists grappling with what happens to information that falls into a black hole, because quantum mechanics suggests information shouldn't be truly destroyed, have proposed a solution. The information isn't lost inside. It's encoded on the surface of the black hole, its event horizon, like a cosmic hologram. Imagine the surface of a black hole holding a perfect, albeit scrambled record of everything that has ever fallen into it. If this concept, proven for black holes, can be extended to the entire universe, it fundamentally changes our perspective on reality. It suggests that what we perceive as a vast, voluminous, three-dimensional world full of objects and distances is actually just a projection of information stored on a boundary far beyond our direct reach. It implies that everything we see, experience, and interact with, from the smallest particle to the largest structure, is a projection of data held on a cosmic surface. This is a mind-boggling concept, yes, but it's one that physicists are actively investigating through advanced mathematical models and theoretical simulations. They are delving into the mysteries of black holes and exploring the implications of this holographic nature, trying to see if the numbers add up, if there are testable predictions. Their work could revolutionize our understanding of space, time, and the very nature of existence. The journey to understand if our universe is a hologram is just beginning, and it promises to be an exciting, perhaps paradigm-shifting adventure into the unknown. Now let's talk about another piece of this cosmic puzzle: entanglement. Imagine two particles, perhaps billions of miles apart, linked in a deeply mysterious way. They share a bond that seems to defy the usual rules of space and time. When you measure the state of one particle, say its spin, you instantly know the state of the other, no matter how far away it is. This instantaneous connection, this seemingly spooky action at a distance, is one of the strangest phenomena in quantum mechanics. It challenges our common-sense notions of locality, the idea that something here can only be influenced by things immediately around it. Entanglement could play a crucial role in the universe's potential as a quantum computer. By instantly linking particles across vast distances, it might enable a form of cosmic computation that is incredibly efficient, allowing different parts of the universe to communicate and synchronize in ways far beyond our current technological capabilities. It could be the underlying mechanism that ensures different corners of the cosmos stay connected, allowing the grand cosmic computation to proceed smoothly and coherently. This synchronization might be absolutely essential for the universe to function as the unified whole we observe. But just like any computer program, especially one of unimaginable complexity running reality, what happens when errors occur? Even the most robust systems can experience glitches. In our computers, a single bit flip in the wrong place can crash a program. If the universe is a vast computation, wouldn't errors arise in the cosmic code? Just as our sophisticated computer systems need error correction mechanisms, complex algorithms, designed to detect and fix errors automatically to maintain stability and integrity. The universe might have its own inherent ways of dealing with these potential glitches in the cosmic computation. Perhaps quantum error correction, a cutting-edge field in quantum computing research, holds clues to how the universe maintains its incredible stability over billions of years. These cosmic correction mechanisms, whatever they are, would be crucial for preserving the delicate balance of existence and ensuring the universe's grand computation continues without interruption. Let's revisit those cosmic giants, black holes. Often portrayed as purely destructive forces, cosmic vacuum cleaners that swallow everything in their path, some theories suggest they play a far more sophisticated role. What if they aren't just destroyers, but also information processors, vital components in the universe's computational architecture? As we discussed, the idea is that black holes don't annihilate information, they encode it on their event horizons. In this view, Black holes are like cosmic hard drives, storing vast, unimaginable amounts of information about the universe, everything that has ever fallen into their gravitational grip. But they might be more than just storage. If the universe is a quantum computer, black holes could be its most powerful processors. They could be crunching through colossal amounts of data, manipulating information in ways we can barely comprehend, potentially shaping the very fabric of space-time and influencing the universe's evolution through their information processing capabilities. Understanding how black holes handle information could unlock some of the most profound secrets about the nature of reality itself. So, we've journeyed from the starlit sky to the fundamental particles, from strange quantum behaviors to the mind-bending idea of a holographic reality projected from a boundary, all suggesting that the universe might be a form of gigantic quantum computer, managing information through entanglement and error correction, with black holes acting as cosmic storage and processors. These are just theories, yes, frontiers of physics that challenge everything we thought we knew. But the fact that many serious scientists are exploring these possibilities tells us something incredible. The universe is likely far more wondrous, complex, and perhaps fundamentally different than we ever imagined. What does this mean for us? If reality is, at its core, information and computation, does that change how we see our place in it? Perhaps. If the universe is interconnected through things like entanglement, perhaps it reminds us of the deep, often unseen connections between everything, between us and nature, between each other. Our actions, like tiny changes in a cosmic computation, might have ripple effects we never perceive. If reality is more like a projection or a complex code, it encourages us to look beyond the surface, to question our assumptions, to seek deeper understanding not just of the cosmos, but of ourselves and the world immediately around us. It suggests there are hidden layers of meaning, complex processes at play, even in the seemingly simple moments of our lives. And if systems need stability and error correction, perhaps it's a cosmic reminder that maintaining balance and harmony, identifying and correcting our own errors or negative patterns, is essential for healthy systems, whether they are relationships, communities, or even our own internal well-being. Ultimately, these ideas, while abstract, fill me with an even greater sense of wonder. They tell us that the quest for knowledge, the desire to understand, is one of the most meaningful things we can pursue. The universe is a profound mystery, and we are part of its ongoing story, its ongoing computation. What do you think? Does the idea of a universe as a cosmic computer resonate with you? Or does it feel too much like science fiction? Does thinking about reality this way change your perspective, even just a little? Share your thoughts in the comments below. Thank you so much for joining me on this journey into the mind-bending possibilities of our universe. It's a wild ride, isn't it? I hope this exploration has sparked your curiosity as much as it has mine. Wishing you all good health and a universe full of wonder and discovery. If you enjoyed diving into these cosmic mysteries, please consider subscribing to the channel and hitting that notification bell so you don't miss our next exploration of the universe's deepest secrets.